In this video, we're going to talk about drawing rotations on a coordinate plane. Now we're going to focus on rotations around the origin, and we're going to look at our rotations in 90-degree increments. Why is that? Well, because a coordinate plane is made up of an x-axis and a y-axis, which are perpendicular to each other, and divide that coordinate plane into 4 quadrants, which are right angles. So if I wanted to rotate this red point 90 degrees clockwise around the origin, I could draw a line segment from this point to the origin, then draw a perpendicular line segment, which would run along the x-axis and the same length as the other line segment, and this would be the location of my new point. Now, once you get the hang of what a 90-degree rotation looks like, you could just recognize that the original point was on 3 on the y-axis, and a 90-degree step would then place it on 3 on the x-axis. If I rotated another 90 degrees clockwise, that would put me on -3 on the y-axis, and 90 plus 90, that's 180, so that would be a 180-degree rotation. Yet another 90 degrees would now put me on -3 on the x-axis, and 90 times 3 is 270 degrees, so that would be a 270-degree clockwise rotation. And another 90 degrees would put me back where I started. 90 times 4 is 360, and that would be a 360-degree rotation. Now this table here to the right gives you the algebraic rules for what happens to the ordered pair of a point when you perform a specific type of rotation. Now it may appear that some rotations are missing from this table, but they're all covered here, and here's why. If we take a look here, 90-degree rotation counterclockwise, well, that looks like this. Well, that's the same thing as a 270-degree rotation clockwise, which looks like this. You would end up at the same point. So the rule is a counterclockwise rotation of x degrees is the same as a clockwise rotation of 360 minus x degrees. So for example, in a 90-degree rotation counterclockwise, 360 minus 90 is 270. So that is the same as a 270-degree rotation clockwise. So let's take a look at this example here, and it's important to note what I have written in blue. It says, when no direction is specified, assume the rotation is counterclockwise. So when they don't give us a direction to rotate in, it's going to be counterclockwise. So we need to rotate this quadrilateral ABCD 270 degrees counterclockwise. So 270 degrees is 3 90-degree steps. So if we take a look at point A here, it is on 2, positive 2 on the y-axis. If I move 1 90-degree step, that puts me on -2 on the x-axis. If I move another 90-degree step counterclockwise, that puts me on -2 on the y-axis. And my third 90-degree step counterclockwise to complete my 270 degrees, that puts me on +2 on the x-axis. And that is the location of my new point, A prime. So if you look at the algebraic rule for a 270-degree rotation counterclockwise, it says x comma y becomes y comma the opposite of x. So let's take a look. Our pre-image of A was at 0 comma 2, and our image of A prime is now at 2 comma 0, which the y value switched, and -0 is still just 0. So this is working so far. Now the rest of the points are a little trickier. Some of you might see it and some of you might not. So let's rotate B, our 3 90-degree rotations counterclockwise. So if you look at B, B is 1 step off of the y-axis at +4, right? So if I rotate it 90 degrees counterclockwise, I'm going to end up here, which is one step off of -4 on the x-axis. And then if I rotate another 90, that's going to put me here, one step off of -4 on the y-axis, and again one more, and that's going to put me here, one step off of +4 on the x-axis. And that's the location of B prime. Looking at point B, it was at 1, 4, and B prime is at 4, -1. So you see the x and the y value switched, and we took the opposite of the x value. So this is correct. So now let's rotate point C. We can see that point C is 2 steps above 4 here on x. So when we rotate our 90 degrees counterclockwise, we're going to end up right here. And another 90 degrees, we're going to end up right here. And finally, our last 90 degrees, and that's going to put us right here. And this is C prime. So C was at 4, 2, and C prime is at 2, -4. So again, that works because the x and the y value switched, and we took the opposite of the x value. Finally, let's do point D. So we see point D is above 3 on the x-axis, so a 90-degree turn is going to put us here. And then another 90-degree rotation is going to put us here. Turn the rotation, same thing. And then our final 90-degree rotation is going to put us here. And so this is the location of D prime. So once again, we see that D was at 3, 1, and D prime ends up at 1, -3. And so now all that's left is to connect the points together. So A to B, B to C, C to D, and D back to A. So this is our rotation of quadrilateral ABCD 270 degrees counterclockwise, which again is the same thing as 90 degrees clockwise. All right, so in this next example, we need to rotate triangle KLM 180 degrees. Now, when you're rotating 180 degrees, it doesn't really matter if you specify clockwise or counterclockwise. You're going to end up in the same location. So if I look here at K, and I'm going to move it 180 degrees, so I'm going to go 2 steps of 90. I'm 1 under 2 on the x-axis. So one step is going to put me here, and the next step is going to put me here. So here is the location of K prime. So let's move L. So L is 1 step under 4 on the x-axis here. So 190-degree step is going to take us here, and the next 90-degree step is going to take us here. So this is the location of L prime. Finally, let's rotate point M. So we see point M is 1 to the right of -4 on the y-axis. So our 90-degree rotation is going to take us here, and our next 90-degree rotation to complete the 180 is going to take us here. So this is the location of M prime. Now we need to connect the dots, but before I do that, let me move K prime down here, and we're going to connect. And so this is our rotation of triangle KLM 180 degrees. So now let's take a look at the algebraic rule. It tells us that on a 180-degree rotation, x comma y becomes the opposite of x comma the opposite of y. So negative x comma negative y. So looking at k was at 2 comma negative 1, and k prime is at negative 2 comma 1. So we can see the opposite of 2 is negative 2, and the opposite of negative 1 is positive 1. L is at 4 comma negative 1, and L prime is at negative 4 comma 1. And again, the opposites. And finally M was at 1 comma negative 4, and M prime is at negative 1 comma 4. So all 3 points in our rotated image fit the algebraic rule. All right, I hope this video helped you to understand drawing rotations on a coordinate plane.